Hello, discrete math fans. If we use the Euclidean algorithm, we'll be able to find out that the GCD of 1239 and 735 is 21. We'll do that in a minute just so that you can see it. We're going to use this fact to help express 21 as a linear combination of 1239 and 735. This is what Bézout's identity tells us, is that we should be able to do this. Now what we're going to describe here is something called the extended Euclidean algorithm. It does everything that the Euclidean algorithm does, but goes one additional step. Now let's just run the Euclidean algorithm as we usually do. Every step that we take, we're going to note the new remainders in blue. We're going to use those numbers in the next step. All right, so I don't want to go through the nitty-gritty of the details. These are the calculations that are involved in running the Euclidean algorithm, and you can see that we end up with an answer of 21. What I want to do is show you how we're going to use these numbers. All right, so all this calculation tells us that the GCD of these two numbers is 21. So Bézout's identity tells us that there must exist integers s and t such that 21 is equal to 1,239s plus 735t. We're going to describe how to actually find those integers. Now, if that equation looks a little funny to you, keep in mind that s and t do not need to be positive. In fact, in this case, it's pretty easy to see. One of these is going to have to be positive, and one of these is going to have to be negative. I'm talking about s and t. Okay, so let's talk about how we're going to work backwards. Now, it may be helpful if you wrote down the equations from the previous slide that told us how we got to 21. We're going to be working our way backwards. Notice that we took one of those equations and solved for 21. So we get 21 is equal to 231 minus 5 times 42. What we're going to do now is take the 42 and solve for that. So we have an equation in there which will tell us that 42 can be written as 504 minus 2 times 231. A bit of algebraic manipulation, and we get that 21 can be written as 11 times 231 minus 5 times 504. Now we've got 231 highlighted. We take one of the equations that we had before and replace that. We have an equation that tells us that 231 can be written as 735 minus 1 times 504. So we'll put that in there. Now let's do a little bit of cleanup. This now is equal to 11 times 735 minus 16 times 504. Now we've got 504 highlighted. Let's replace that. So 504 can be replaced with 1239 minus 1 times 735. Once again, a little bit of algebraic manipulation. And we get 27 times 735 minus 16 times 1239. So we've done it. We're able to write 21 as 1239s plus 735t, and all we have to do is pick s to be equal to negative 16 and t to be equal to 27. All we had to do was rewind all the calculations in the Euclidean algorithm computation. Okay, that's all for now.